time zone, and good morning to everybody else. It's a pleasure to be with you today. I'm sitting in for a first time as moderating one of these. Phil Winters typically handles those. And we're going to start with just a little introduction to CUTR for those of you that aren't familiar with it. We're a research center that's been created by the state legislature in Florida about 20-some years ago now, located in Tampa at the USF campus. Hang on, I skipped one here. And we do a fair amount of applied research. We're a little bit unique, and we have a dedicated research faculty. So while we're involved in teaching, we're not traditional tenure-track teaching faculty. And we have about 45 faculty full-time, as well as support staff and students. So we're a significant sized entity. We do a lot of technology transfer and training, like we're going to move quickly on to today. Very multidisciplinary, and most of our faculty have a number of experiences, not just academic, but also for various agencies, etc. So we pride ourselves on bringing the state-of-the-art methodology to very real-world problems. Here's just some metrics for our operation. Again, a good-sized faculty, a fair number of active students, and significant project list that continues to rotate as new projects come and go over time. We'll be talking about one of those projects that we completed in the past year today. We are very multimodal. We tend to have a stronger focus on public transit than is typical in research centers. It's a strong niche for us, and one that was important to Florida when we were formed, and is certainly important to the nation. And this kind of previews some of the types of activities and programs that we have. I'd encourage you, those of you that want to learn more about our center, to go to our website, use those various links, and I think you'll find a wealth of resources that are all readily available and convenient and free to users. So certainly encourage you to take advantage of that. We do have a few quick poll questions that we'll go through here, and if you could answer these quickly, just so we can get some metrics of who's paying attention and who's out there in our audiences, and obviously refine our methods and approaches to be sensitive to that over time. Not surprisingly, it's mostly individuals and a good attendance for a very technical topic area today. Again, we appreciate folks being with us. You can give us a quick click on where you're located. Strong West Coast presence. Florida's coming up in the numbers. So those East Coast folks don't want to miss lunch, I guess, but and your type of agency, if you could, please. I guess what we'd expect, lots of MPO folks, they're going to be strong data users, and I think the tool you're going to be exposed to today will be very helpful, and as well as a smattering of other folks. And if you could just respond to whether or not it's the first time. We try and keep this intro material to a minimum, recognizing that if you've done one of these before, you don't want to hear it again, but we do have a lot of first-time visitors, depending on the topic area, and of course we need to orient them to what we're doing. So about almost 60% first-time visitors today. Thanks very much for participating in that. We appreciate your data there. That helps us. The The speaker today is Dr. Chu. He's been with USF since '93 and been helping us, certainly myself and others here, for that full time with a breadth of clients all over the country. He's got a BS in mathematics from Hangzhou University in China and a PhD in economics from University of California in Irvine. He's widely published in a variety of publications like Accident Analysis and Prevention, ITE, our Journal for Public Transportation, Journal of Urban Economics, Regional Science, Transportation Economics and Policy, and Transportation Research, and Transportation Research Record publications. He also does a lot of refereeing and serves on and has served on some editorial boards in areas like transportation safety and security. The work he's going to focus on today is part of a policy or portfolio of work he's done with a lot of statistical work on National Transit Database sampling methods and then the American Community Survey Statistical Analyzer. And with that, I'll turn over the program to Shay Howe and be back with you to take questions and moderate questions at the end. Again, you can type in questions as we go, but we'll have a round at the end to respond to your questions. Again, thanks for being with us.
Well, thank you, Jennifer and Steve. Let's start again. You know, the title is the ACS Statistical Analyzer, and what we are going to cover. We are going to briefly cover what ACS is and a brief contrast with the long form, traditional long form survey. And we are going to talk about the concept and the measurement of precision of ACS data and its usage. Then we are going to describe the Excel tool, which is the statistical analyzer, and we are going to do a little demonstration of a few of the functions of the tool. And at the end, we will talk about some specific items, essentially more like applicability of the tool and when the user needs to be careful in using the tool. Well, the ACS, of course, just like the census data designed and administered by the U.S. Census Bureau, and the instrument is similar to the traditional long-form survey, including social, demographic, and housing data, and also economic and journey to work data. But the administration of the ACS is very different from the administration of the traditional long form in several ways. Here are the major 5 ones. One is the residence rule. The ACS uses the current and at least 2 months as the residence rule, but the long form uses the usual residence rule. And of course, the ACS is a continuous measurement, but the long form is based on basically one day, April 1st, during the census year. And then for a few variables, particularly household income and school attendance, the reference period differs between ACS and the long form. And then, of course, the ACS is done annually versus every 10 years for the long form, and most importantly, and which the main reason why we are talking about this today is differences in sample size. Roughly, the ACS samples 1 housing unit per 40, which is about 2.5% versus 1 in 6 for the long form, which is about 16.7%. So. And keep in mind these differences in using a tool, also in your generally in using ACS data too. I always forgot. Okay. Okay. So what data are available from the ACS? Basically, there are 2 type of data products. One I call them the pre-derived estimates by the Census Bureau or another organization. And then the second type is subsamples. in terms of the pre-derived estimates, there are several formats of pre-derived estimates. One is certainly the published tables at American FactFinder. And then you have the ACS summary files. And for transportation usages, you have the CTPP tables from at the FHWA's CTPP sites. But then also pre-derived estimates have two different types that are important to separate and keep in mind when using this tool. One is that place of residence characteristics, and most of the data are related to residence characteristics. But then you have place of work characteristics that you're talking about characteristics related to a particular work site rather than the residence site, because they have implications in terms of the applicability of the tool. And then lastly, subsamples for the ACS, we have 1% PALMS data sets by state, and only geographies at least with at least 100,000 population is identified. So they're only useful really for large geographies. Well, the data release and the data availability depend on the temporal period and also geography. And geography is divided into three groups: large, with at least 65,000 people; medium, from 20,000 to 65,000; and a small, anything under, including block groups. And 5-year data are only, well, for small geographies, 5-year data is the only option really for small. And for large areas, all different time period data are available. Most of you know these, but just for completeness, I'm going to go over these quickly. Okay, now this is important. What forms do data estimates take? Here we address 6 forms. Frequencies, persons, households, housing units. The totals, we're talking about the aggregate amount of certain characteristics of households, including, for example, total income, commute time, wages, etc. And then also averages, medians, and ratios, and then percentages. Now, for this tool, we separate 2 types of percentages. Frequency-based percentages, for example, the percent of workers who usually commute to work by public transportation, which is frequency-based. But there's total-based percentages. For example, the percent of household income for households under poverty levels, for example, will be a total-based percentages. We distinguish these 2 type percentages because the statistical procedures and formulas differ when we analyze their position and compare them. In general, experts and the Bureau of Census has suggested that when persons and organizations use ACS data individually or compare different estimates across areas, population groups, or time periods, they must take into account the reliability of the data, more statistically, the sampling error or precision of the ACS data. So this is important, and this is basically the motivation for this tool and the similar tools others have provided. Well, just briefly, what does the precision of an estimate indicate? Basically indicates how close the different estimates from different samples are close to each other. So you have 4 examples there. The two on the top are more precise than the two at the bottom, although their levels of accuracy are different between the two columns, which we are not going to talk about, but mainly we focus on precision. So some people may ask, okay, where do I get these multiple estimates? Well, theoretically, for a given design of a survey, you can do repeated sampling of a population, and for each sample you get an estimate for the same characteristic, and that's where you have these multiple crosses. And the better, the closer they are, the better in terms of precision. Well, what can we use to measure precision for estimates? There are four that are involved here. Two are independent of confidence levels, and two are dependent on confidence levels. The two independent of confidence levels include the standard error, and which is the basic concept, and then something we have called the relative reliability here, but more in terms of standard of a term, it's really the coefficient of variation. It's the standard error normalized by the estimate itself, and then here we present it as a percentage, so we have 100%, 100 multiplied by that ratio. And then the two measures that depend on our confidence levels are the marginal error, which are presented in our published ACS estimates from the Bureau of Census. And depending on the level of confidence used, the marginal error will differ for a given level of standard error. The example here given is for the 90% confidence level. And then, of course, the confidence interval, basically the interval with the estimate as the center and with the marginal error as the half length. Okay, so where can we get the measures position for particular estimates? For published estimates from the ACS website, they come with an marginal error already at the 95% confidence level, but there are no other measures of precision we mentioned earlier. So for people who want to get other measures of precision for these estimates, you may use this tool, or of course you can do it yourself. And then for CTPP, most CTPP estimates, ACS estimates that I looked at the last year, most come with a margin error already at the 90% level of confidence, but some don't seem to have those, which could have changed, I don't know. And then for a lot of other the estimates, the user will need to derive measures of precision. Here, some examples. Anything published for Census 2000, CTPP 2000 estimates, Census 2000 PALMS data, and user-derived estimates from any of the published estimates, or from ACS PALMS. So there are other possibilities, but here certainly the major ones, different ways that you may get measures of precision, and the tool covers all these different ones. What's the AC data may be used for? Of course, there are a variety of possible usages, and one certainly popular usage is to indicating the condition of a geography or population group using individual estimates, such as the average commute time for a city, median household income for a state, percent of workers commuting to work by transit, etc. But then, it's popular to compare. See if there are differences between estimates. Those comparisons can be over time for a given geography or population, or at a given time you cross population groups or geography areas. And the tool basically is more useful for these two particular purposes. But of course, ACS data are far more useful than those, and we are not going to cover here. But so we are talking about precision, and then the question is, are my data or my estimates precise enough to find my purpose, or basically are my estimates usable for my purpose? So how do I know? Here, the marginal error is an absolute indicator of precision, and typically is not that effective to indicate whether or not a particular estimate is usable for your purpose. Here, the relative reliability measure comes in. It's a relative indicator of precision, and it's far more effective for that purpose. So the question is how, what criteria do I use? People have indicated some general guidelines, which is cited in the report, the guidance to use the tool. In general, an estimate will be usable for a lot of purposes if the relative reliability is under 10%. Remember, the smaller the better. The user should be cautious to use an estimate if its relative reliability is more than 10%, but under 50%, and then the user should avoid anything if it's about the relative reliability is about 50%. Now, we are not talking about usages for modeling purposes. Okay, we are talking about the specific two purposes we mentioned earlier. And then also you need to consider the importance of an estimate. If, for example, if you are using an estimate related to funding allocation of funds, then you might want to target a lower level of relative reliability for comparisons or for using a particular individual estimate. So it depends on your specific case. Okay, how can precision may be improved for a particular application? These are all general guidance from the Census Bureau. For a given period, you combine geographies into a bigger one, or combine small population groups into a larger one. And similarly, for a given geography or population group, use estimates for a longer period. We mentioned earlier you have 1-year estimates, 2-year, 3-year estimates, and 5-year estimates. You use a longer period estimate for this purpose. I need to move on, I think. And then, of course, the comparison. What do we do? How can we compare two estimates statistically? I'm going to skip that. The presentation, the tool covers that. Basically, you conduct the test of significance, and the tool will help you to do that. But one thing I want to mention is the last bullet here. I guess I haven't been using this. You should use a higher level of confidence for your test if the conclusion is important. Again, funding is just an example. Also, if you are doing a lot of compares at the same time, you might want to use a higher level of confidence because there is the random chance of a comparison being found statistically different, but actually it's not because you are doing a lot of comparison at the same time. Okay, so how does the ACS Statistical Analyzer help? Well, it derives measures of precision. It tests help you to conduct a test of significance at a level of confidence you select. And it does these for 6 different forms of estimates I mentioned at the beginning. And it focuses on ACS data, but also deals with census data too. it's a 2003 census-based, Excel-based template. It covers 4 general functions, and under those 4 functions, there are 15 sub-functions. And they are the individual sub-functions you would use for different purposes. And the user just need to enter some basic required data, and the tool takes care of the statistical procedures and formulas involved. In the report, and also you'll see in the first sheet of the tool, these tools and procedures are listed there for people who are interested. Okay, function A. Focus on estimates that already have a 90% margin of error, but no other measures precision. Mostly, ACS published ACS estimates and the CTPP estimates. It's labeled as A01-ACS. It allows up to 100 estimates be done at the same time, preferably from the same table, because then you have the general description that's applied to all 100 estimates. So this is the simplest of the different functions. And function B, that's a little bit more involved among all the different sub-functions. It's mostly useful for dealing with Census 2000 data, because it derives measures precision for estimates that do not have any measure of precision. So here we have 5 sub-functions. The first one actually deals with ACS PUMS estimates, using so-called replicate estimates. The other ones are mostly for Census 2000 data. But, can be applied to ACS data if you don't have any precision measure. Here we include average, medians, frequencies, and percentages. I want to emphasize here the B05 frequency applies to frequencies, not totals. And B06 percentage applies to frequency-based percentages, not total-based percentages. I'll cover that a little bit more at the end if we have time. And here we mentioned that B3 and B4 is based on a distribution table as an input. And then the B5 and B6 is based on a design factor as an input. I'll just briefly mention some of these. What's replicate estimates? They are supplemental estimates to any ACS estimate that a user can obtain from a ACS PUMS data. Every ACS PUMS file comes with a full weight for somebody to get the ACS estimate. And there are also 80 replicate weights for getting replicate estimates for the same quantity you're trying to estimate. And then these 81 estimates combined can be used to determine the precision measures for the particular estimate. And ACS Direct, BO2, is used for that purpose. But the users need to have these replicate estimates derived before using this tool, because this Excel cannot handle PUMS data. The raw PUMS data are too big. So the users still need to do those separately before they use this tool. A distribution table is very simply like this. Here is a distribution table in terms of travel time to work, and you have the ranges of travel time and then the number of workers for each range. So we will see an example of using this. And the design factor, for large sample surveys, typically the sampling process is not simple random sampling, and as a result, the estimates have larger standard errors than otherwise. So there's a design factor to adjust these estimates to reflect the fact that the sampling was not simple random. For Census 2000, the design factors vary by state, by the characteristic, and also by sample size. These design factors by state are included in the tool in the last tab. For ACS, design factors vary by state, also the characteristic. But since the Census Bureau may change these design factors over time, not every year, but occasionally, so they have not been included in the tool. If you are dealing with an estimate that is a combination of two or more characteristics, use the larger design factor for these different ones. And the design factor used for 4 different subfunctions here. Okay, what does function C do? This is very straightforward. Basically derives measures precision for estimates already from 2 or more estimates that already have a margin of error. So we have 6 functions covered here: sum, difference of 2, percent difference, ratio, percentage, and product. And probably sum is used more often than most others. So we will demo the sum. And then function D. Function D is what the tool uses to help you to conduct a test of significance. There are 3 subfunctions. The first one, D13, labeled as ACS and ACS, basically allows you to test 2 ACS estimates that already have the margin of error come with it. The next 2 are for comparing an ACS estimate and an estimate from 2000 census, long form. Here we have 2. Let me mention the third one, D15 first. Here we simplifies the test by assuming that the standard error or the marginal error for the 2000 estimate is the same as the ACS estimate. If so, when you do that, use that function, and if the conclusion was that the difference is found statistically significant, then the result is valid. But if the difference is not found statistically significant, then actually it's not valid result. So then the tool suggests you to go back to use D14, which means that you need to come up with a marginal error for the 2000 estimate before you use this. And certainly you can use some of the other subfunctions in this tool for that purpose. We have a demo on that too. Here's the demo, I guess. We have planned for 6 subfunctions here for the demonstration. We will see if we will have time for all of those. But it's a brief demonstration. I'm not trying to go through each one in detail. For example, how to get data from the ACS website, etc. I'll just do take some shortcuts in the demo. So for that, I'm gonna bring up the analyzer first. It has 15, 16, 17 tabs. This is the cover tab. Briefly introduce, motivates, and describes the functions which we covered already. And here the PDF files listed in column K, basically the guidance for using this tool. And
say how we're not seeing it on the screen right now.
Okay, I'm sorry. Which part are you not seeing?
The spreadsheet.
Oh, not seeing it?
No.
I'm sorry. Okay, just hold on a second. I need to share. Sorry. Share, but I'm sharing the desktop. Okay, I need to share the desktop. Hold on just a second. Can you see it now?
Yes.
Yep.
Okay, sorry. Okay, go back. Okay, I know.
This is when everyone, you may want to use the full screen mode that we talked about. So just use the F5 key to see it in full screen, and you'll see more of what Shehao is trying to demonstrate.
Okay. Yeah, so again, there are 17 tabs. This is the cover sheet, describes the tool, the functions. And then here, can you see? Can everybody see the PDF inserts in column K? They describe basically the guidance of using this tool, and the combination of these different pieces are the reports available at our CTR website. And then this big table indicates which function is applicable to which forms of the estimates, the 6 different forms we mentioned earlier, and what source of data that these estimates come from. And then some credits. I'm not going to go over there. So let's go to the first application of the first subfunction, A01 ACS. Again, this is for derive other measures of precision for ACS estimates that already have a marginal error. So in this one, in all of these sheets, there's an introduction describes what you need to pay attention to, what's the usage, what data are needed, what are conditions, and how you may enter the data. And then in most cases, we have an example. In this case, we do have one. And then at the bottom of each tab, then you have the tool, I guess. You enter data for. In this, what I'm going to do is simply copy the data I already have in the example into the tool, and in general, I suggest that you paste as values. And then you see once you paste that data, not all results are shown yet, because you still have to enter the desired confidence level and the year of data for these estimates. Let's say I want 9/5, and the year of data, I think it's 2008. So here then you have the full set of results available for these 7 different estimates. You're trying to get alternative measures of precision. And I have skipped the copy, the description of the estimates, which is all there. Typically, you want to enter those so that you will not be confused in terms of what you're dealing with. So in general, you hear is the relative reliability comes first, and then confidence interval at the 90% level, and then the other all measures of precision at an alternative confidence level you'll have entered. So that's very straightforward, and it's up to 200 estimates you can enter here in this subfunction. So the next one is B02 ACS Direct. So what this does is to help you to determine measures of precision for ACS estimates that you get from ACS PALMS data sets. And I'm not going to go over in detail for the introduction portion. Here we don't have an example, but the results are shown first in this case because the input data takes more space. So the results will be shown here once we enter the input. The input, basically is a desired level of confidence for the estimate, and the measures of precision, and then the main input, which are the estimates, the main estimate, and then the estimate replicate estimates. There are 80 of those. And what I'm going to do is have a copy, a set of replicate estimates already Then from PALM's data, ACS PALM's data, so what I'm going to do is just highlight the data, including the headings, and just copy it. Where's copy? Copy it, bring to tool, and then paste as values. Okay, let's go back. Here, we have the estimates come out already, but we still need to enter the desired confidence level, let's say 95. Once you enter that, and then all measures of precision will be shown up here. The margin of error, relative reliability, and confidence bounds, and then standard error. So it's straightforward. Of course, to do this, you need to have the replicate estimates ready first, which depend on what tools you use, software you use to tabulate PALM's data. So the next one, I think, is B03 average. Here we are talking about trying to get the measures of precision for estimates of averages. You don't have any measures of precision. So in general, you're talking about Census 2000 data that can be applied to ACS data too, if you don't want to use replica estimates. Here we have an example, and then we have the tool again. So what I'm going to do is copy the data for our demo. Okay, so we're going to copy the distribution table, and it describes how you should enter the distribution table in the tool. So what I do is I'll bring it here, copy, paste, value. Okay, and then very importantly, you need to type in last to indicate what is the last row of your distribution table, because the calculation tool uses that. I couldn't find a better way of taking care of that, so that was the one of the requirements of data entry. And then you need to enter the source of data. In this case, it's Census 2000 data, so I enter 1. What else I need? Yeah, see, this is an example. I'm going to just copy these, and then I'm going to briefly talk about these. Okay. The first one here is the estimate itself. You may already have an estimate from like 2000 census, but you don't have the measures of precision. And then the desired confidence level, of course. The next two I didn't mention in the presentation before the demo. One is the sample size in terms of percentage, which is 12% here in this case. And then the design factor I mentioned earlier. You can get from the attached PDF files that's in the last tab of this tool. So in this particular case, it's 1.4. So once you enter all these, then let's go. Where's the results? Okay, results are here. Okay, so you can certainly enter a description if you want to. But here is the result. This is repeating the estimate above there, but this is the margin of error we estimated, and then the other measure position. Now look at this. The relative reliability is only 0.9%. So this estimate, 28.1, is very good in terms of precision. It's higher reliable in this particular case. So the next one is percentage. Again, I want to emphasize that its frequency is based percentages here. Okay. Again, the layout is similar. Introduction. An example is shown. And then the calculation. So what I'm going to do again for this case to save time is I'm going to use this example, the data in the example for my demo. So what you will have is the estimate itself you already have, which is 11.1%. I'll enter that here. Or maybe I should need to bring it up a little bit more. Okay, so I have entered here. And then I need to enter the source of data, which is one, I think, is Census 2000, published estimates. And then I need to copy these other input items. Now, when you use this, of course, don't copy those. Then you will be in trouble if you do that. Okay, again, briefly, the first one is your desired confidence level. Next one is the denominator used in getting the estimate. Remember, we are talking percentages. So if we are talking about mode usage for commuting, then this will be the total number of workers in the geography you are talking about. If it's something's population-based, then it's the total population. The next is the sample size, again, in percentage terms. And the last one is the design factor, 1.4. So once you enter all of those, you have the measure of positions. In particular, the marginal error at the 90% level is 0.45. For this estimate, and then the relative reliability is 2.5. Good, because we're talking about Miami City, so it's a relatively large city with a large population, so the sample is very large, and so the estimate is pretty good. Okay, and the last one. Let's estimate. Let's go to, okay, I won't be able, I don't know if everybody can see the tabs, but I'll bring up the tab where you will compare an ACS estimate and a 2000 estimate using the actually measured precision for the 2000 estimate. Okay. Again, introduction, we have an example. And then the tool. So what I'll do is, so I'm gonna copy the data for the ACS estimate, which you're gonna get from the ACS website, or you derived yourself. And then I'm going to use, just for comparison, I'm going to use 95 again as the desired confidence level for the comparison. And then for the 2000 estimate, we have the 11.1 estimate. The marginal error we already derived from the previous demo, which is, B06 percentage. We determined that the marginal error is 0.45, and that marginal error was associated with the 90% confidence level. Here we go. Then we have the oh, I'm sorry. I shouldn't copy that. I need to do some of. Oh no, yeah. Okay, you can't. Then that's the input. The output is here. Okay, the output is column K. Whether or not the 12.3% from ACS in 2008 versus the 11.1% from 2000 census, whether or not they are statistically different at the 90% marginal, 95% marginal such a confidence level, and the result of yes. By the way, if you use the other one, if you assume that the 2000 estimate has the same level of margin of error as the ACS estimate, then the conclusions will be not valid. And so you can use that in this particular case. You need to come back to this one for a conclusive result. Okay, I don't know if anybody can see that. Just briefly, this is a tab where it lists all the design factors by state for 2000 census. Okay, so that's all the demos. Let me go back to my presentation. I have 3 more slides, just briefly go over. Okay, let me go to the next one. Okay, what should a user avoid when comparing ACS estimates? These are, again, guidance for using this tool, also guidance for using ACS estimates in general. You should avoid estimates that overlap, in any form, between geographic areas, between population groups, or across multi-year periods. You should not use this tool to compare ACS estimates if that such overlapping occurs. And then you should avoid the following comparisons for multi-year estimates. You don't want to compare a multi-year period with a single-year period, or you don't want to compare 2 multi-year estimates with 2 different lengths. And then lastly, you generally don't want to compare a pre-2006 period versus a post-2006 period, mainly because group quarter population is included in the post-2006 one, but not in the previous one. So if you know there are no such populations in the geography you are talking about, then it's okay. But if you know there are such populations, then you don't want to do such comparisons probably. What should you consider when comparing ACS and the 2000 estimates? Basically, you need to consider the effects of the main differences we discussed at the very beginning of the webinar when you do such comparisons. If these effects are going to impact the results, then you want to avoid such comparisons. The effects of residence rules, effects of seasonal variation, because one is continuous and one is just a snapshot of April 1st. And lastly, differences in reference periods for household income and school attendance. So you need to think about whether or not these differences between the 2 surveys might impact your area. And so you want to be careful. Okay, last 2 slides. Mentioned 2 types of pre-derived estimates. One is place work characteristics. The other one is place of residence characteristics. I want to emphasize that most of the B sub-functions should not be used for dealing with place of work characteristics because they are not designed for. So I said must not use those. So be careful of that. However, you will be able to estimate the precision measures for place of work characteristics if you are using ACS PALMS data. And you use the B02, the ACS direct subfunction. You can do that for those characteristics, but not the B subfunctions. I mean the B30 through B06. Because we don't know some of the sampling characteristics of place of work sites, because the sampling was based on residences, not workplaces. Lastly, I mentioned earlier that one of the 2 subfunctions is for derive precision measure for percentages, but those are frequency-based percentages. So here specifically BO6 and BO5, they should not be used for total-based measures. So in order to get measures of precision for totals or total-based percentages, you will need to take several steps to do that. Here, just an example. I understand it's kind of awkward, but this is what the tool can offer. For total income, for example, what you do is to get measures of precision for average income first using BO3. And then you get a measure of precision for the total number of households using BO5 frequency. And then lastly, use C12 product to get measures of precision for total household income. Of course, more steps that are involved, that less reliable the results going to be, but that's the best we can do. And similarly, you may use multiple subfunctions for total-based percentages, but different combinations of subfunctions for that. Okay, maybe I'm going too fast. I think that's the last one.
Mm-hmm.
Any questions?
I don't see any questions posted. We will stay on here for several more minutes if folks do have a question. Here's the instructions on the screen in terms of how to do that. And as we wait to see if anyone wants to weigh in with any, I will mention we want to thank our sponsor for that research, FDOT, as part of our National Centers program, where they've been kind enough for years to match our federal funding for our National Center for Transit Research. So we appreciate their ongoing support for that program. And you've been, the tool is obviously available, as what referenced earlier on. You've got Dr. Chu's email address. If you have some questions as you work through that, don't hesitate to send him an email, and we'll see what we can do in responding to you. If not, like I said, we'll hang in there a little bit longer and wait for some questions. I see one here now. Do you know enough about the NHTS to comment on major overlaps and differences with ACS? And Shehal, I'll let you take that. He certainly does know a lot about the NHTS as well. We do a lot of work with that.
Well, certainly social demographics data, if you call that overlap, both surveys have a lot of social demographic data and commuting information from both sources. But of course, the sample for the NHTS is much smaller than the ACS, although we are complaining about the sample size for ACS. So that needs to be taken into account. And also, the NHTS has a very similar question on journey to work data as the ACS data, so they are entirely comparable. But the main difference is sample size and geographies. So I think that
the 2008 American Community Survey was used as the basis for sample weighting.
Oh, you're talking about common weights, yes, for total, control totals, state totals, and some of the other sampling, subgroups are controlled by the 208 ACS data. That's true in terms of come up with the weights, but in terms of data content, they do share quite a bit there.
Okay. We had another question on attaining the analyzer. If you can just repeat, Shehal, for folks who might have missed it earlier.
Yes, the analyzer, I think, is downloadable as part of this meeting.
Yes, it is, Shehal. I was just going to remind everyone in the upper right-hand corner, it's the icon that looks like 3 sheets of paper. Just click on the icon, and you'll see all of the options that you have available for download. One of those is the Excel spreadsheet. That's the Statistical Analyzer, and then also today's presentation. So that's just a reminder for everyone where to find that.
Okay, and another option, of course, is to search for the title, the ACS Statistical Analyzer. You will get either to our NCTR webpage where it's available, or the FDOT's website. So that's another option. Or you can ask me.
Yeah, or email say. One other thing, this presentation is being recorded, so this will be posted in a few days on the CUTR website. So if you've got colleagues that you want to refer to this, feel free to do that. And like I said, it'll be posted within a few days on the CUTR website. Okay, we don't have any other questions, but we do an evaluation of these, seek your feedback. So if you could, we'd really appreciate if you take a few moments and complete this. And like I said, this is an ongoing series of webinars that we're doing bi-weekly. So we do use the feedback to help us shape future presentations, and as well as on other topics, as well as future presentations on this for various other audiences. So we appreciate your input.